In part 2 of this video, I'd like to do a few more example problems that are similar to what in video 1, as well as talk about some shortcuts, some alternative methods to this process of making a box for factoring these trinomials. Recall, as in the previous video, what we said, if we want to factor or unmultiply this, we want to undo that process of that we would do for multiplying. And again, what we started with was we wanted to try to turn this 3-term polynomial into a 4-term polynomial. And how we did that was we played the multiplying and adding. The multiplying, how we made a multiplying problem is we took the first and last terms together and multiplied them. The adding part of this adding game is the middle term. And we said what multiplies to 14t squared but adds to 9t. Well, we focused on the multiplying side of things. What numbers multiply to 14 are 14 and 1 and 7 and 2. And hey, what do you know? 7 plus 2 is 9. So like 7t and 2t. We'll solve this. This means that this polynomial is better written as t squared plus 7t plus 2t plus 14. This is the answer to a multiply question. We multiplied by using a box. The squared term was almost always in this upper left-hand corner. This constant term was always in the bottom right. And then these terms were one of these two. It does not matter which order you put them. I'm going to do the 7 and the 2. We said our factors are just whatever would be on the outside of this box that makes this as an answer. So we just need to find what are each of these 4 terms, and then these on the outsides multiplied together will be the factorization, or the 2 things that multiply to make t squared plus 9t plus 14. We did that by finding one thing in common in either a column or a row. To me, I see the thing that jumps out at me is that in this first column on the left-hand side, t squared plus 2t, there's a t in common. Is the most in common between them. And once I know that this is a t, then the rest just falls into place. If this is a t, then to make t squared, I need a t here. To make a plus 7t, well, here's the t part, and I need a plus 7 up here. In order to make plus 2t, well, here's the t, and I need a plus 2. And we check, does plus 2 times plus 7 equal this last box, multiply to make this last box? Yes, it does. 2 times 7 is 14. So this tells me that this polynomial factors to t plus 7 and t plus 2. So this is fine, and you can practice this more, and that's what the homework and the learning target practice on big ideas is going to be for. But what I'd like to notice is some shortcuts. So this process, while useful and nice and will always work, if you're clever, you'll note that there's in some certain situations that we don't need to do all this process. That in fact, note that the leading coefficient of everything we worked on so far is 1. And as long as the leading coefficient is 1, then it turns out that there's a nice pattern. First of all, the first term is always just, if we start with a t squared, then the first term in each of the 2 factors is t. And it's just the square root of this first term, or just t. It also turns out that the 2 numbers that we have here, plus 7 and plus 2, what do you know? Those happen to be just the 2 numbers that we came up with in our adding and multiplying game. And this is going to be always true as long as the leading coefficient is 1. So the 2 numbers that end up in our final polynomial will always be the same as the 2 numbers that we chose at the end of our multiplying and adding game in the situation where the leading term is 1. Put that together, what that means is I don't need to actually do a big box here to factor leading coefficients with the leading term as 1. So if I can do the multiplying and adding game, then I can actually solve. I can factor this without doing all this extra work in the middle. So let's see, it multiplies to 12x squared, but adds to 8x. See, numbers that multiply to 12 are 12 and 1, and 6 and 2, and 4 and 3. And let's see, which of those pairs add up to 8? I think 6 plus 2. You could then continue what we did with make a box, write out this polynomial, and make a box and so on. Or maybe I take advantage of the shortcut, knowing that since the leading term is 1, that the numbers that are going to end up in the parentheses that I'm going to write are just 6 and 2. So I think I can shortcut all this, and I know how this polynomial leading coefficient 1 is going to factor. It's going to be, since the first term is x squared, I'm going to have x's here at the start, and then the remaining numbers are whatever I came up with. I think that's positive 6 and positive 2. If you are not sure, or you think that maybe you want to check to make sure you did this correctly, you could check to see if you could check your work here. What are we going to do? Well, if we multiply our answer out, this factorization is unmultiplying, so we should be able to multiply this back out and end up with what we started with. So we could just do a quick check by multiplying this back out and seeing do we get what we start with. X times x is x squared. X times 2 is plus 2x. 6 times x is plus 6x. And 6 times 2 is 12. And combine these like terms, and we get x squared plus 8x plus 12. And that is what we started with, which means that confirms that x plus 6 times x plus 2 is the correct factorism. Again, this trick will work no matter, as long as the leading term is 1. So we can, if you are clever and you know your multiplication facts, we can rip through these factoring problems in a hurry. I'd like to show you using the box one. Now we get some subtraction symbols in odd places, but I'll show you how the box works for, like, say, one of them, and then we'll use the shortcut to do the remaining 2. Our multiplying game should be 3x squared, and now our adding game needs to add up to minus 4x. And I think the numbers multiplied as positive 3 but add the negative 4 are negative 3 and negative 1. In this case, negative 3x and negative 1x. So I think this is better written as x squared minus 3x minus 1x plus 3. If I use a box, I will put the x squared here, the constant term down here, and then these two terms somewhere inside. I'm going to try to find what's in common in one of these columns or rows. I like this left column here. I see an x squared and an x, so I think that an x is in common. And now I can I'll try to fill in the rest of this box. I think x times x is x squared. What times x times what is minus 3x? I think I need a minus 3. What times x is minus 1x? I think I need a minus 1. And I check, is minus 1 times a minus 3, whatever in this box? Yes, two negatives multiply to make a positive. So I think x minus 3 and x minus 1. Note, minus 3 and minus 1 are the numbers, the answer to our multiplying and adding game. So I could have jumped right to the end. Knowing that, maybe we'll use the answers to our multiplying and adding game to try to solve the rest of these. Again, they all have leading coefficient of 1. So the multiplying game would be, the multiplying part would be 12t squared. The adding part should be minus 8. So what numbers multiply to 12 but add to minus 8? Well, let's see, 12 and 1 multiply to 12, they don't add to minus 8. 6 and 2, if both were negative, minus 6 and minus 2 would add to minus 8. So I think our answer is minus 6t and minus 2t. So our shortcut, our pattern that we noticed, tells us that this should factor without needing a bit box or anything to two groups multiplied together. They each are going to have a t, and then the numbers to fill in are going to be minus 6, minus 2. Again, if you're not confident, or you just want to check to make sure you did it correctly, you could distribute this back out, FOIL this or box multiply, however you want to do, and check to make sure that the answer you get is what you started with. 2 more, and then we'll be done with this video. M squared plus n minus 2, the leading coefficient is 1. So my trick should apply. I'm going to multiply the first and last. The middle term is adding. M, or how about 1m? So I need a pair of numbers that multiplies to minus 20 but adds to 1. To multiply to be negative, one's going to have to be positive, one's going to have to be negative. And when I add a positive and negative, that's like subtracting. So the answer here is going to be a number, two numbers that when I subtract them, the answer is 1. Again, because one's going to be positive and one's going to be negative. So the numbers that multiply to be 20 are 20 and 1. I can't subtract 20 and 1 to get to 1. 10 and 2, 10 minus 2 is will never be 1. How about 5 and 4? 5 minus 4 is 1. So I think the answers to this problem are 5 and minus 4. Again, 5 plus negative 4. 5 minus 4 is 1. And 5 times negative 4 is negative 20. Again, you could put these you could split the middle term into each of these two terms and then use a box if you so choose. I'm going to skip that because I know the leading coefficient 1, and I know that that I'm going to take advantage of this pattern that we've noticed. M squared is beginning, so I'll have an m and an m. And then the numbers that go in here are 5 or positive 5 and minus 4. Minus 16w squared and adds to 6w, to positive 6w. Again, multiplies to be negative, so if we multiply to be a negative, then that means one's positive, one's negative. And adding a positive and negative number is like subtracting them. So I need two numbers that multiply to be 16, but when I subtract them, I get 6. Let's see, numbers multiply 16 are 16 and 1, which do not subtract to be 6, or 8 and 2. 8 minus 2 is 6. So how about 8 and subtract 2, or minus 2? W. So again, taking advantage of our shortcut, because the leading term is 1, I know that this problem is going to have this structure of w squared, so I'm going to have w's here, positive 8, and negative 2. And negative 2, not negative 8.